Hi everybody. So today I'm going to try to do a quick rough sketch of a diagram of an AC system, the major components, how they're connected, and basically what the state of the refrigerant is throughout the system of a vehicle. Now I know it's going to be a little hard to identify because I'm drawing this with my fingers on this view board, so we'll give it a shot and see how well it turns out. So anyway, I always like to start at the main component or the heart, which I consider the compressor, the AC compressor. So I'll just put a component up here to represent maybe our compressor. We'll label that COMP. Hopefully you can see that okay. Compressor will have two lines on it, discharge and suction line. So I'm going to go to the discharge side of this, and this is going to be the type of system I'm going to talk about is a cycling clutch orifice tube system, also referred to as CCOT, or cycling clutch orifice tube. So we got our compressor, we've got a discharge line leaving the compressor. The discharge line will go out and go to a major component. And this is going to be the AC condenser. Now the condenser usually sits out in front of the vehicle, in front of the radiator. It's the furthermost cooling component. If you were to look at the front of the vehicle, you probably, if you're looking through the grille, are going to see the condenser in that location. That'll be the first thing you see. It looks like a mini radiator, and it's similar in a lot of ways. Other than running engine coolant through it, we're running AC refrigerant through it. So we leave the compressor, and what is the state of the refrigerant as we leave the compressor? Well, we are dealing with a high pressure gas leaving the AC compressor going to the condenser. So it enters the condenser as a high pressure gas. The goal here would be to eliminate some of the heat or transfer some of the heat through the ambient airflow going through it. So typically on the back side of this, we're going to have either an electric fan or a belt driven fan, something that will draw air through it to transfer that heat. So as we come into the condenser, we're coming in as a high pressure gas, and as we dissipate or get rid of some of that heat, the refrigerant will condense to a liquid. However, it's still high pressure. So we're going to leave the condenser as a high pressure liquid. This line is usually referred to as the liquid line in the AC system. This is where we still have high pressure, but hopefully all of the refrigerant has changed state from a gas to a liquid now. So where do we go now? So if we continue this line, we're going to come to another component in the AC system, and this is where we're going to have a pressure change. This is where we're going to go from a high pressure liquid and drop it to a low pressure liquid. So this is the orifice tube in the system. Orifice tube is where we have a pressure change. So we have two locations now where we're going to have pressure change. The first being at the compressor. We go from a low pressure to a high pressure. The second is at the orifice tube. We're going to go from a high pressure to a low pressure. So as we leave the orifice tube, we are coming out as a low pressure liquid is our goal. We then enter another major component, and this component is referred to as the evaporator. In the AC evaporator, it's located behind the dash in the passenger compartment. This is where we're going to take either the air within the cabin area or outside, which we refer to as fresh air intake or recirc air. So this air will be drawn through the evaporator and then blown out the register, whether it be the vents, the floor, the defrost area, wherever the driver wants to direct the airflow. So we're coming into this as a low pressure liquid, and as it moves through this and we're blowing warmer air across it, we're taking that liquid and we're changing it to a vapor. We're heating it up a little bit is the goal here. So the refrigerant will absorb some of that heat of the ambient air being flown through it and cause the refrigerant to boil. And the boil will cause it to change from a liquid to a gas. So as we leave the evaporator, we should come out mostly as a low pressure gas. That's the goal. However, that doesn't always happen. So there still could be some liquid coming through here. What we don't want to have happen is send liquid refrigerant back to the compressor. If we do that, we can't compress a liquid. We can compress a gas, but if we try to compress a liquid, we're going to damage the compressor. It's no different than you filling up the cylinders in your internal combustion engine with water or coolant, and you try to start that motor. You're going to what's called hydrolock. You have something that cannot be compressed and you're going to try to compress it. So something's going to break. So we need to make sure we don't have liquid refrigerant getting back to the compressor. So we add another component. This component is referred to as the accumulator, and an appropriate name. An accumulator accumulates liquid and will only allow gas or vapor to pass through. Okay? So as the refrigerant moves into the accumulator, all the liquid will drop to the bottom. The outlet line draws from the top. So any gas within here will be drawn into that line and carry it to the compressor to complete the entire loop. Okay? So we will ensure that we don't get any liquid refrigerant to our compressor. So the accumulator is just that, it accumulates liquid. The other thing that's inside this accumulator is what's referred to as a desiccant bag. Now, if you've ever bought a pair of tennis shoes and you open it up in the box and you look and there's that little bag in there, right? It sounds like there's salt in it. Well, that's desiccant material, and what that does is that absorbs moisture. So we do not want to have any moisture in this system, and so to ensure that, we put one of those bags inside of the accumulator to absorb any moisture in there. We don't want to contaminate our refrigerant. We need 100% of whatever refrigerant we're running in this system to make sure that it's optimal and running at its most efficient state. Okay, so that's it in a nutshell. Yeah, review this if you need any more input. All right, good luck.